Hello and welcome to my sixth tutorial offering mathematics support to Open University students studying the module TM111, Introduction to Computing and Information Technology. Today we're going to be looking at multiplying and dividing powers of 10. But before we start, let's just remind ourselves of any number raised to a power, and the main base number, here I've called it n, can represent a number like 10 or 2 or 5 or 7, and we say it's raised to a power of a, where a is shown as a little superscript character. So we might come across numbers like 10 raised to the power of 6. This represents a million. Here we would say the base is 10 and the power is 6. But as technologists, as we've seen in previous videos, that we have to be comfortable dealing with large and small numbers, and we now need to be comfortable with handling the calculations involving these numbers. In the tutorial on large numbers, we looked at 1,000 times 1,000, which made a million, and we saw that this could be represented as 10 to the power of 3 times 10 to the power of 3, giving us 10 to the power of 6. Remember, the 6 is showing that there are a million represented by 1 followed by 6 zeros. We saw we could multiply a million by another 1,000, and this gives us what we call a giga. So 1,000, which is 10 to the power of 3, multiplying a million, which is 10 to the power of 6, gives me 9 zeros, 1 followed by 9 zeros, and we write this as 10 to the power of 9. So can you see a bit of a pattern that's appearing here? 10 to the power of 3 times 10 to the power of 3 gave me 10 to the power of 6. 10 to the power of 3 times 10 to the power of 6 gave me 10 to the power of 9. Basically, we can see there's a rule here, a rule emerging that says basically when I multiply two numbers together, as long as the base value is the same, in this case it's 10, I can just simply add the powers together. So if I had a number like 10 raised to a power of a multiplied by 10 to the power of b, when I multiply those two numbers together, I will actually get a value of 10 to the power of a plus b. Let's have a look at some other calculations. Here I'm going to divide. But we saw when we looked at the video on small numbers that I can represent a number like divide by 10 to the power of 15. I can represent that as being multiplied by 10 to the power of minus 15. When it's on the bottom, it moves to the top line and it changes its sign. So if I've got 10 to the power of 25 divided by 10 to the power of 15, I can write this as 10 to the power of 25 times 10 to the power of minus 15. Now, because I'm multiplying, I'll obey that previous rule. I'll add the numbers together. 25 minus 15 gives me 10. So we can see this very, very simple rule that we've seen that we can actually apply in many, many different applications, multiplication as well as division. So when we multiply two numbers together with a base value of 10, we can simply add the powers together, although some of them may be negative. Okay, let's have a look at another calculation. Here I've got 10 to the 25 divided by 10 to the minus 5. And if we think about 10 to the minus 5, it's a very, very small number. It's a fractional number. And here I'm dividing a big number by a fractional number. And if we divide any number, like say 10, if we divide it by a fraction, say a half, we get a bigger number. It's really saying how many halves are in 10. There are 20. So we always end up with a bigger number. So here we'd expect to see an answer with a bigger number. But we're going to obey the rules. When it's on the bottom, it's dividing. I can move it to the top, change its sign, and then multiply. So here, my 10 to the 25 is going to be multiplied by 10 to the power of minus 5 moved to the top. I change its sign. Minus 5 will become plus 5. And now I'm just doing a very, very simple multiplication. 10 to the 25 times 10 to the 5. I add the powers together again to get 10 to the 30. Okay, so again, we can obey our rule of multiplication, and we can apply it to division, whether the divider is a positive number, a big number, or a very small number shown by a negative power. Let's just have a look at some examples to finish off with. What happens when we multiply 10 to the power of 20 by 10 to the power of 4? Well, we just simply add the powers together. So we'll get 10 to the power of 24. 10 to the power of 2 divided by 10 to the power of 4. Remember, 10 to the 4 is on the bottom line, so we bring it to the top and change its sign. It'll become 10 to the minus 4. Add them together, and we'll end up with 10 to the power of minus 2, because 2 minus 4 gives me an answer of minus 2. Next one, let's have a look at the next one, is 10 to the power of 15 times 10 to the power of 42. Well, just multiply them together, so we'll just simply add the powers together. 42 plus 15 is 57. 10 to the 29 divided by 10 to the 14. Again, just very simply bring the 14 from the bottom to the top. It becomes 10 to the power of minus 14. Add the two numbers together, and I'll end up with 29 minus 14 gives me 10 to the power of 15. My final calculation is 10 to the 20 divided by 10 to the minus 4, and that will give me 10 to the 20 times 10 to the power of plus 4, because I'll bring it to the top line and change its sign. So therefore I'll get 10 to the power of 20 times 10 to the power of 4 will give me a simple answer of 10 to the power of 24. So that's multiplying powers of 10, but I want you to keep in your minds that this applies to any number raised to any power. So as long as the base number is the same, so n raised to the power of a times n to the power of b will always give me n to the power of a plus b. Likewise, when I divide, so if I have n to the power of a divided by n to the power of b, that will always equal n to the power of a minus b. Now, in this case, today we've been looking at n as being equal to a value of 10, our denary system. But it can represent any number we like. It could represent 5, 4, 3, and importantly 2. And 2 is important when we look at binary numbers, which is very important in computing. Thank you for watching, and more resources can be found on my website shown there with the URL. Hope you've enjoyed the video. Thank you.